Hello everyone, today we are going to learn a new lesson, Unit 2, which is symmetrical figures and lines of symmetry. If we have this polygon ABCD, this polygon like a trapezium, if I cut this polygon into this middle, I cut this polygon into two equal parts, this part and this part. This shape is called a symmetrical shape or symmetrical figure. Symmetrical figure. So the figures, all figures that can be folded around a line, this line cuts the figure into two equal parts, like this part and this part. Two parts match exactly. This figure is called a symmetrical figure. Again, a symmetrical figure. And this line, which cuts this figure, is called line of symmetry. It's called line of symmetry. So we have take polygon like this. If we cut this polygon into two equal parts, this polygon is called a symmetrical figure. Symmetrical figure, and the line that we cut it is called line of symmetry. The first type of the symmetrical figures that have only one line of symmetry. Like this, the first one, if we take the isosceles triangle like this, if I need to make a symmetrical line, I will do this line. It will be only one symmetrical line of symmetry. If I do this line, it will be not symmetrical because this part not equal this part. Okay, so if I do another one in this way, it will be not symmetrical shape because this part, not equal, not match exactly like the down part. So the isosceles triangle only has one symmetrical line. One line of symmetry. Okay? The next one, the isosceles trapezium. This trapezium is isosceles. This line, this side equals this side. We call this trapezium and isosceles trapezium. Also, this isosceles trapezium has only one line of symmetry. We will cut this trapezium into two equal parts, like this. This part equal this part, right side equal, match exactly the left side. Okay? If we do another line to cut this trapezium, like this. This line, not a line of symmetry, because the first part, the up part like this part, not the same, the down part is very different than this. Okay? So this line in the middle, this line is not a line of symmetry because the two parts are not match exactly, like this, are match exactly. Okay, so the isosceles trapezium has only one line of symmetry. And the last one here is a polygon. No, it's an open curve. It's not a polygon, it's a figure, an open curve. If I need to cut this here into two equal pieces like this, in the middle, like this. The right side, we see the right side are match exactly the left side. So we call this figure a symmetrical figure, and this line is called a line of symmetry. If I need to cut this here into two equal pieces from the middle, horizontally like this side, the up side, is not equal, is not the same with the underside. Okay? So we have only one symmetrical line, one line of symmetry in the here and the isosceles trapezium and the isosceles triangle. The next one, asymmetrical figures have more than one line. have 1, 2, 3, 4, whatever. More than one line. First one, the rectangle have two lines of symmetry. We know that rectangle have two dimensions, length and width. If I cut this rectangle horizontally like this line is a line of symmetry. This line is called a line of symmetry. And if I need to cut this rectangle into this part vertically like this line also called line of symmetry. So rectangle, any rectangle which have upside length or width have only two lines of symmetry. The next shape, the next figure, the equilateral triangle. The equilateral triangle we know have all sides are equal in length. Equilateral triangle, all sides are equal in length. If we need to get the line of symmetry of this figure, first one I will cut the first side like this. Number one, number two, cut the next side like this. Number three, cut the third side like this. All sides are equal in length and all sides are cutting in the same side. Okay, if I need to get this line, this side are symmetry of this side are equal. Okay, and if I need to get this line, this side are similarly of this side. Okay, so the equilateral triangle has only three lines of symmetry, has no more than three lines. The next shape, square. Square, we have the square. We know the square have the all sides are equal in length. All sides are equal in length. This side equal with this side, with this. All sides are equal in length. So if I need to get the line of symmetry of this square, of any square, we will cut the square like this. Number one of line. Number two, cut the square. Okay, in the middle. Number three. Number four. Then we get 1, 2, 3, 4 lines of symmetry. So square have only 4 lines of symmetry. The next figure, rhombus. Rhombus. If I need to get the line of symmetry, we first make a vertical one like this. This part are similarly with this part. So this figure is called a symmetrical figure, and this line is called a line of symmetry. The next one, horizontally like this, not a diagonal. I know the third point from here and here, the line between them is called a diagonal, but this is called a line of symmetry. Okay, line of symmetry. So a rhombus, any rhombus with any side of length has only 2 lines of symmetry. 1, 2 lines. Okay. The next one, regular hexagon. Regular hexagon. Regular hexagon mean all sides are equal in length. All sides are equal in length. This means a regular hexagon. Hexagon means 6 sides. Hexagon, 6 sides. If I need to get the line of symmetry like this, first one, horizontally. Number 2, vertically like this, vertically like this. Number 3, number 4, number 5, Number 6. All these lines are called line of symmetry. So the hexagon has 6 sides and also have 6 lines of symmetry. Hexagon has 6 sides, so we have 6 lines of symmetry. The last shape, the last figure, the circle. Circle like this is not a polygon, it's an open curve, so it has an infinite number of lines of symmetry. If I do that horizontally like this first one. If I do this line called line of symmetry, passing through the center of this circle. If I do this line also called line of symmetry, like this. If I do this line, also called line of symmetry. So any circle has an infinite number of line of symmetry, has no end. That's mean of infinite number, has no end of number. I don't know the number of the line of symmetry of the circle. Okay, has infinite number of line of symmetry. Okay, any circle. The next one, first one we see the symmetrical figures. The next one we see the non-symmetrical figures. Non-symmetrical figures, that mean have no line of symmetry. If I cut any figure from the non-symmetrical figures, the two parts are not matched exactly as we see in the symmetrical figures. So the first one of the non-symmetrical figures, scalene triangle, all sides are different in length. All sides are different in length. Okay, if I need to get the line of symmetry, if I cut this side like this part, the upper part is not symmetry, not like this part. So this line is not a line of symmetry. Let me get another one. If I cut this triangle like this side is not like this side. So this line is also not a line of symmetry. Do another one. We make this. If I do this line is not a line of symmetry. Why? Because the first part, the up part here, is not in the same, not like the down part. This part is not like the first part, the up part. So the scalene triangle, any scalene triangle, has no lines of symmetry. The next one, the trapezium like this. First one, the symmetrical figures, we say the isosceles trapezium. Isosceles, two sides have the same length, but in this trapezium, these sides are different than these sides. So we call that only trapezium. If I need to cut this trapezium into two equal parts, if I cut this like this line is not a line of symmetry, because as we see that this part is not the same part, this part. Okay, so this line is not a line of symmetry. Let me try another one. If I cut this trapezium like this part is not similarly like this. This part is not similarly like this. So this line is not a line of symmetry. If I try this line, also this triangle is not as this triangle. So the trapezium, not the isosceles, only trapezium has no lines of symmetry. And the last figure, parallelogram has also no lines of symmetry. If I need to cut the parallelogram like this, This part, the left part, not equal, not the same part, not like the same part. So this line is not a line of symmetry. And if I try another part, another line like this, if I take this line, I see that the first part is much similar like the down part. But if I do this part, I put this part on this part, it will be different. If I cut this part by scissors, like this, if I cut this part and cut this part and do this, put this part on together, you will see that there are different. So if I cut a parallelogram by any symmetrical, by any lines, it will be not a symmetrical figure. So parallelogram also has no lines of symmetry. This is the non-symmetrical figures. Thank you.